Students, as we have started our chapter limits and derivatives and we are doing exercise 13.1. So now we are going to start with sum number 24 and we have to find here limit x approaches to 1 of the function where the function is given for all x less than or equal to 1 we have the function x square minus 1 and for all x greater than 1 we have this function. So if I just show this thing on the real number line, okay, so if I break it here for 1, it is given for all x less than 1, right? For the left hand limit we have the function x square minus 1 and for all x greater than 1, right, so we have function here minus x square minus 1, right? So when x approaches to 1 from the left hand side, that means left hand limit we will calculate, and when x approaches to 1 from the right hand side, here we are going to calculate RHL. And if LHL, RHL both coincide at this point, that means both are equal, then only we can say that limit of the function exists. And if the same answer is coming, that will be the answer of this part, that limit x approaches to 1, what is f of x, okay? So here we will calculate left hand limit and we will write down limit x approaches to 1 from left of the function. So here we will write down limit x approaches to 1 from left, and which function we have for the left hand limit? X square minus 1. We will directly apply the limit. So this negative sign is representing that x approaches to 1 from the left side. So when we apply the limit, it will be 1 square minus 1, so that is 0. Now we will calculate RHL, and when we calculate RHL, it will be limit x approaches to 1 from right. Plus sign is representing that this is the right hand limit function. So when we apply the limit, it will be limit x approaches to 1 from right. So here the function is minus x square minus 1. Let us apply the limit here. It is minus of 1 square minus 1. So minus 1 we are having here minus 2. LHL answer is 0. RHL answer is minus 2. So we will write down as left hand limit is not equal to right hand limit. So the conclusion will be limit x approaches to 1 f of x does not exist, right? Either we can write down this way or we can write down inverse, that limit of the function fx when x approaches to 1 does not exist. So this is our sum number 24. Now we have sum number 25. And sum number 25, we have to evaluate limit x approaches to 0. Evaluate limit x approaches to 0 f of x, where the function is given now. The function is given mod x upon x for all x not equal to 0, and it is taking 0 value when x is equal to 0. Now here if you notice, the function is defined in a different way. It is not like slack inequality and strict inequality, but here when x not equal to 0, we have function mod x upon x, so that is the signum function. And when x is equal to 0 means when x is 0, the function is taking 0. So this is what does this mean? It means f of 0 is given 0. We are given the value of the function at 0 is 0. So when x is not equal to 0, so if I show here once again on the real number line, so when here it is 0, okay, this is minus infinity and infinity. So when x is 0, f of x is also 0, right? But when x is not equal to 0 means when x approaches to 0 from left side, when x approaches to 0 from right side, for both the cases I have this function mod x upon x, okay? When x is approaching to 0, not equal to 0, but when it approaches to 0 either from left or right, I have this function. So what we will do here, we will calculate LHL and RHL, right? And we will find what is the limit of this function when x approaches to 0. So let us do it. So here we have the function mod x upon x, okay? And I'm just going to now define it on the basis of when x is less than 0 and when x greater than 0, how the function will come, okay? So it will become, when x is less than 0, equal to 0 I cannot take, it will be strict inequality for both the cases, because when x equal to 0 the value is given 0 already. So when x is less than 0 I will have mod of minus x, okay, upon minus x, because x is less than 0. So mod of minus x, it will give you x only, and here it is minus x. So x upon minus x, it is giving me minus 1 directly. And when x is greater than 0, I will get here mod of x upon x, because x is positive. So it will give me x upon x, that is 1. Either you do define here itself, or the other way, what I will do here, I will calculate left hand limit. When I calculate left hand limit, it will be limit x approaches to 0 from left, the function is mod x upon x, right? Now when x approaches to 0 from left, the function is here. If you notice one thing, if I just apply the limit directly, I will get 0 upon 0 form, right? And 0 upon 0 form, that means indeterminate form. So here I have to avoid this 0 by 0 form, and then what I am going to do, I will substitute. Now the question is what I will substitute here. I will go for, when x is approaching to 0 from left, that means if this is 0, x is approaching to 0 from left, here the number will be less than 0 only, okay? So I will just substitute here, put x equals to 0 minus h, some number which is less than 0, and this h is very very small. We will put x is equals to 0 minus h, where h is positive and negligibly small number. You can write down very small, okay, such that when x approaches to 0, now if x is approaching to 0, definitely h will also approach to 0, right? So the limit will change and it will become, so left hand limit will become limit h approaches to 0. Now wherever x is there, we will put 0 minus h, 0 minus h upon 0 minus h. Now here the same thing I will get. Here I have directly applied the definition, but here I am going to do, which, if I hope you people remember, this is the definition of signum function only. For all negative values of x, the function will take minus value. For all positive values of x, the function will take 1 value, okay? So here now I will apply the definition of modulus function. Mod of minus h will give me h only, and 0 minus h I will have minus h. H upon minus h, that means I am getting limit h approaches to 0 minus 1. Now minus 1 is constant, limit is h approaching to 0. So the answer will be minus 1, because there is no h, I cannot apply the limit. So directly minus 1, right? And now if I calculate RHL, RHL will be limit x approaches to 0 from right function. The function is same only. So limit x approaches to 0 from right, it is mod x upon x. So now here, that means x is approaching to 0 from the right hand side. So it will be 0 plus something always, okay? So what we will do here, we will put x equals to 0 plus h, right? So that when when x approaches to 0 from right, h will approach to 0. And this substitution will help us to get this answer in the easy way. So the right hand limit will become limit h approaches to 0 modulus of 0 plus h upon 0 plus h. That means limit h approaches to 0, it is h upon h is 1 only. So here I have limit h approaches to 0 of 1. Answer will be 1. Right? So left hand limit is coming minus 1, right hand limit is coming plus 1. What does it mean? Left hand limit is not equal to right hand limit, so the limit of the function does not exist. Same thing I have done here. First of all, I applied the definition of signum function, and then if I calculate here also, right, when I calculate left hand limit, it will be limit x approaches to 0 from left of minus 1 answer will be -1. Limit x approaches to 0 from right of 1, because now the function is -1 for all x less than 0 and it is +1 for all x greater than 0, right? So directly our answer will be that limit of the function does not exist. So here we will end. We will write down as LHL is not equal to RHL. So limit of the function does not exist. Limit of the function does not exist. This is how we will conclude it, right? So this was the sum number 25. It is the signum function. And sum number 26. Sum number 26 is the same kind of, where here we have mod x upon x. In sum number 26 we have x upon mod x. So same way as I have applied we have calculated LHL and RHL, and I made the substitution for the left hand limit. It will be x equals to 0 minus h. So here we have mod x upon x. In 26 x upon mod x. So one and the same thing. Here I am getting h upon minus h. In sum number 26 I will get minus h upon h. There also left hand limit answer will be -1 and RHL will be +1. Okay. So sum number 26 I am leaving for you people. You can do that. Sum number 27 also, it is homework. Directly you people have to calculate limit x approaches to 5 f of x, where the function is given mod x minus 5. Directly we will apply the limit. There is no need to break it. So when I apply the limit, mod of 5 will be 5 only. So 5 minus 5 is 0. So the answer you are getting 0, right? And now we will discuss sum number 28. So in sum number 28 we have, suppose this is the function given. For all x less than 1, a plus bx is the function. For x equal to 1, the function is taking value 4. That means f of 1 is 4. For all x greater than, we have the other function. Now the condition is given, if limit x approaches to 1, f of x is equals to f of 1. That means limit of the function is equal to value of the function at 1. Then we have to find the values of a and b, right? So if this thing is equal, when I said limit x approaches to 1, f of x is equal to f of 1, that means left hand limit will be equals to right hand limit, and both these limits are equals to f of 1. So I'm just going to write down as limit x approaches to 1, f of x is equals to f of 1. And what is f of 1? F of 1 is 4. So it implies limit x approaches to 1 from left will be equals to limit x approaches to 1 from right, and both these will be equals to f of 1. So from this condition, I will get left hand limit is also equal to 4, right hand limit will also be equal to 4. Two equations we will get, two unknowns a and b are there. We will solve the equations to get the answer. Okay, I am repeating. If it is given limit x approaches to 1, f of x is equals to f of 1, it means limit exists. Right, limit of the function exists, and if limit of the function exists, we know left hand limit will be equals to right hand limit. So that definition we have applied, and when the limit of the function is given equal to value of the function, that means both the limits will be equal to value of the function. So let us calculate. We will calculate here left hand limit. So it is limit x approaches to 1 from left of the function. So that is limit x approaches to 1 from left. For left hand limit, that means for all x less than 1, the function is a plus bx. So here it will be a plus bx. Let us apply the limit. It will be a plus b. Remember, negative sign is showing, it is the left hand limit. That means when x is approaching to 1 from the smaller side, means from the lesser side, right? Now we will calculate RHL. RHL will be limit x approaches to 1 from right function, that is limit x approaches to 1 from right. Now from the right hand side, that means for all x greater than 1, the function is b minus ax. So here we will apply this. When we apply the limit, we are getting b minus a. Now we will use this result. Okay, I will equate this So we will write down, therefore a plus b will be equals to b minus a equals to 4, because f of 1 is given 4. So that is a plus b is equals to 4, b minus a is equals to 4. Both the numbers are equal to 4, so we will just calculate a and b. If I just add them, right, so I am getting 2b is equals to a, that is the value of b is 4. Okay, so if I put the value of b 4 there, the value of a will be, if b is 4, a will be 0. Okay, so a is 0 and b is 4 if limit of the function is equal to value of the function. So here in sum number 29, we have the function x minus a1 into x minus a2 up to so on x minus an. It's a polynomial function. Okay, we have to calculate limit x approaches to a1. It is the direct sum. We will just apply the limit here. So when I applied the limit, first thing, limit x approaches to a1 f of x, that is limit x approaches to a1, the function is now x minus a1, x minus a2 up to so on x minus an. Let us apply the limit. So I will get a1 minus a1, a1 minus a2 up to so on a1 minus an. Now a1 minus a1, it will be 0, 0 into all other things, the answer will be 0. Similarly, the second part you people will do, limit x approaches to a f of x, and this a is not equal to any of these a1, a2, a3. So when you apply the limit, it will become a minus a1 into a minus a2 into a minus a3 up to so on, right? So that way you people will do sum number 29. Now next sum number 30 we will do. And sum number 30 is given like that. The function is here, first mod x plus 1 for all x less than 0, and when x is equal to 0, function is taking 0. For all x greater than 0, the function is mod x minus 1. Okay, we have to find for what value or values of a the limit exists. Okay, we have to find for what values of a limit x approaches to a f of x exist, right? For all the negative values of x, I have one function. For all the positive values of x, I have other function, and when x is 0, the function itself is 0. We have to find for what values of a, that means what should be this a so that the limit of the function exists. Now if the limit of the function exists, right, we know what is the condition. What is the condition? That left hand limit should be equals to right hand limit. Okay, but we have here, first of all, because a we don't know what is a. If we don't know a is 0, because if I have to check the limit at x equal to 0, I have one function for all x, means when I calculate left hand limit, I have this function. When I calculate right hand limit, I have the other function. Okay, so this question how we will do, there we will consider different cases. When x is a negative, when this a is a negative real number. When a is a negative real number, we have the function mod x plus 1. I will calculate the limit. Definitely I will get the answer. Second, I will consider a case when a is positive real number. For all positive real numbers, we have this function. Then also limit will exist. We will see that. Even we will do it also. And the next thing we will check for when a is 0. Okay, means when a is 0, what is the limit? Limit x approaches to 0. When x approach to 0, is the limit existing or not existing? That also we will see here. So let us start with the case 1, when a is a negative real number. So case 1 we will write down. Case 1, when a is negative real number. Okay, for a, now we know for all x less than 0, the function is mod x plus 1. So directly it means when I apply the limit x approaches to a. Now this a is a negative, but here I am not going to show anything. This a can be any negative real number, -1, -2, -3, any fraction, anything, any real number it is, but it is negative, the function, right? We will apply limit x approaches to a. What is the function? Mod x plus 1. So when I apply the limit, it will be mod a plus 1. Now modulus function will give every time positive answer. When a is negative, then also it will make it positive. So mod a will be a only. So the answer is a plus 1. It means when I am calculating the limit here, the answer is there. It is a definite answer. So it means when a is a negative real number, the limit of the function exists. We will write down for a less than 0, limit x approaches to a, f of x exist. Now second case we will discuss. What will be the second case? Second case we will discuss when a is a positive real number. Okay, so when a is a positive real number, which function we have? For all x greater than 0, for all positive real values of x, the function is mod x minus 1. Once again, we will calculate the limit x approaches to a, f of x. So it will be limit x approaches to a, the function is mod x minus 1. So it will be mod a minus 1, that is a minus 1. Again, some definite answer is coming, a minus 1. That means when a is a positive real number, then also limit of the function exists. Remember, here I am not calculating LHL, RHL. Why? Because for all the values of x, that means for all negative real numbers, this is the function. So when a is a negative real number, I have only one function. Directly I will calculate the limit. And for all positive real values of x, I have the other function. So when a is a positive real number, when I am using this particular function, the answer is a definite answer, a minus 1. Now we will calculate when a is approaching to 0. That means when a is 0, right? So if this a is 0, I will check whether limit x approaches to 0 exists or not. Okay, so let us do that. So case 3 our will be when a is equal to 0, because ultimately what we are checking for what values of a limit x approaches to a, fx exist. For all negatives values of a we have checked, for all positive values of a we have checked, but we have not checked when a is equal to 0, right? When a is equal to 0, now let me show you on the real number line. That means this a is 0, right? And in the definition of the function we are given for all a. Now this x is actually a and a is 0, and for all x less than 0, right? For all negative values of x, the function is mod x plus 1, and for all positive values of x, the function is mod x minus 1. That means when x approaches to 0 from left hand side, I will have this function. When x approaches to 0 from right hand side, I will have the other function. So here when I am checking limit x approaches to 0, right, when a is 0, I will be checking LHL and RHL. So here LHL will be limit x approaches to 0 from left function. So let us apply limit x approaches to 0 from left. The function is mod x plus 1. Let us apply the limit. It will be mod of 0. Directly also I can do plus 1. So the answer is coming here plus 1. And when I calculate RHL, right hand limit x approaches to 0 from right f of x, that is limit x approaches to 0, function is mod x minus 1. And when I apply the limit, it will be 0 minus 1, that is minus 1. Left hand limit is plus 1, right hand limit is minus 1. So we will write as left hand limit is not equal to right hand limit. Okay, so limit x approaches to 0, f of x does not exist. Now we will combine the result of all the three cases. When a is a positive real number, limit exists. When a is a negative real number, limit exists. But when a is 0, limit does not exist. So what will be the final answer? We will say limit x approaches to a, f of x exist for all values of a except at 0. That means limit x approaches to a, f of x exists for all a but not at 0. This will be our final answer, because the question was for what values of a limit x approaches to a exist. So for all values of a it will exist but not at 0. Right? That will be our final answer for this sum number 30. Now we have sum number 31 and 32 that we will discuss later. I want you people to complete the exercise till sum number 30 and then we will discuss the next part. Right? Thank you, students.